Hello again. In this activity, I'm going to show you how to complete the square. So what we need to do for quadratic equations to find the vertex point, and it's just one of several ways, is to convert the general form of the equation into vertex form. In the vertex form, you get your h and k, which is your vertex point, and so you can answer questions like what is the maximum or what is the minimum point. And so taking problem A here, x squared minus 20x plus 5, to complete the square, again, we want to get it into this form here. So we have to make this into what's called a trinomial square. And since 5 isn't a square number, we know it's not a trinomial square. So what we do, we take x squared minus 20x, and we push out the 5 here. Push it over to the side. We haven't really changed anything. And I like to put parentheses around my work. Now, to complete the square, if we kind of do a diagram here to kind of show what we're doing visually, now assuming that this is a perfect square, x squared would go here, and so we would have x and x there. And then in these two boxes of the square, we want to put half of minus 20, so it would be a minus 10x, and this would be a minus 10x as well. And so we know that we have to put 10 here and minus 10 here. And so a minus 10 is going to be 100. So we know we want to add 100 here. You can also find this part that you want to complete, this 100 that we're adding to the equation. You can take half of 20, or minus 20, divide it by 2, which is going to be a minus 10, and you take, and that's what we get over here, minus 10, and then you square it, and it's going to equal 100. So we add 100, and what this makes is a perfect trinomial square, which is x minus 10 times x minus 10. But since we added this 100 here, we have to balance it out, so we subtract 100 as well. And now this part can be written as x minus 10 times x minus 10, which is x squared. So x minus 10 minus 20x plus 100 is everything inside here, but we write it in terms of the dimensions of the square, hence the square. And then 5 minus 100 is minus 95. Y equals. So that is completing the square, going from general form to vertex form. And so we know our vertex point would be, say VP, vertex point, would be 10 minus 95. So from the equation, we can find where that would be graphically and use it to solve various problems. Now, in problem B, what's different about this is that we have a 3 as our leading coefficient, or scale factor. And so that just adds one extra step that we have to do. So remember what we did here. We pushed out the last part, and so we get, say, 3x squared plus 21x.
Good afternoon, staff. Just a reminder that we will start our meeting at 2 o'clock in the cafeteria. Please
Minus
sit with your
5.
House teams. This is a reminder, we'll start our staff meeting 2 p.m. in the cafeteria. Sit with your House Cup teams. Thanks and see you soon.
Sorry about that. And so now we have to factor out the 3. So we want to pull out the 3 in front. So we just divide by 3. So 3x squared divided by 3 is just going to be 1x squared. And 21x divided by 3 is going to be plus 7x. So at this point, all we have done so far is just rewrite it. We haven't added anything, we haven't done anything. But now we want to make this part within the parentheses a perfect trinomial square, and so we can get a box like this. And so the box is going to look, just for a visual representation, we know it's going to be x squared here, and then half of 7x is 3.5x, and then 3.5x. That kind of looks like an x. So we know it's going to be x plus 3.5, and the same over here, x plus 3.5. And so we want to take 3.5 and multiply it, or square it, which gives us 12.25. So we want to add 12.25. So if we add 12.25, we know that this part right here will be, oh, I didn't add it here, $12.25, it's going to be x plus 3.5 times x plus 3.5. So this is going to become x plus 3.5 quantity squared, and you bring down the 3. But what did we actually add here? We added 12.25, but it's a 12.25 times 3. So what we actually added is going to be 36.75. Now, like when we added 100 here, there was no factor here, so we would just do the opposite and subtract 100 to cancel that out or balance it out. And so here, if we actually added 36.75, we want to subtract 36.75, and that would be minus 41.75. So, in conclusion, we can say our vertex point, VP, would equal a minus 3.5 and a minus 41.75. And that's it for this lesson. Thank you.